Hello everyone, this is Anand Goud, Assistant Professor from Civil Engineering Department in Institute of Aeronautical Engineering. So in this lecture, we are going to discuss about the topic compass surveying, in that forebearing, backbearing and included angles and magnetic declination. So coming to the course outcome, at the end of the course, you are going to apply the surveying principles for doing the chain surveying and leveling and contouring for accurate data collection. Okay, after learning about this topic, we are going to do these type of surveying and leveling with proficiency by collecting the data. So now coming to the contents, first we are going to discuss about the topic forebearing and backbearing, and next included angles, and next magnetic declination. Coming to the terms forebearing and backbearing, here see, when we do the compass surveying, okay, when you do the compass surveying, we are going to find out the angles between the two survey lines, right? So here bearing is nothing but it is measured from one station to adjacent next station. So when you take an area, okay, when you prepare a traverse like this, okay, suppose if this is your closed area A, and this is B and C, D and E, okay, so this is the closed traverse. So the definition of bearing is nothing but it is a measured from one station to adjacent next station in the direction of the traverse. Okay, suppose if you do the surveying or traversing in this direction, like A to B and B to C and C to D and D to E and E to A. So now it is the angle measured from one point, one station to the next station in the direction of the traverse. Okay, in this direction, if you're going to do the traverse, so the angle measured between these two, the horizontal angle measured between these two particular lines is called as a bearing. Okay, so now here you can see, coming to the forebearing, if you take two stations, that is A and B, here I have represented. So now this is the station A and this is the station B, right? So now when you sight the station B, okay, when you sight the station B from A, whatever the angle is formed between these two lines, okay, from the north direction, okay, from the north direction, it is making some angle, right? So this particular bearing is called as a forebearing. Okay, so fore is nothing but front angle and back bearing is nothing but backside angle. So now when you sight the station B from point A, from station A, so whatever the angle is forming, so that particular angle is called as forebearing. So here it is represented with the letter alpha. Okay, and next one, coming to the back bearing, so bearing measured from one station to adjacent previous station in the opposite direction to traverse is called as a back bearing. Normally in this traverse, see, the direction of the traverse is clockwise, but here when you sight the station A from point B, okay, it is in the direction of opposite, okay, in the opposite direction of traversing. So when you sight the station A from station B, then the angle formed is called from north to this particular line is called as a back bearing. Okay, so now here you can see this is the station B and this is the station A. Now from station B we are going to sight the station A. So now with north, what is the angle it is going to do? Okay, so here I am representing with the letter beta. So this particular beta is called as a back bearing. Okay, so this is what the back bearing and forebearing definition. So in this example, if you see here, if you take the line AB, okay, if you take the line AB, okay, so here forebearing of AB line is alpha. So here we wrote alpha, and next one, coming to the back bearing of line AB, okay, it is BA. That means it is beta, because the back bearing is equals to beta. Okay, so this is how we are going to calculate the forebearing and back bearing. Simply we can say that if you see the second station, okay, from one station to another station, if you see in the direction of the traverse, okay, that angle will give the fore bearing. And if you sight the station A from station B, okay, that means the direction will be opposite to the traversing. Okay, we are not going to sight in the direction of the traverse, so this particular angle is called as a back bearing. Okay, yeah. Now coming to the relationship between the fore bearing and back bearing. See, the back bearing of a line can be determined if the fore bearing is given. So when you get the fore bearing, suppose this is the station A and here we have station B. Okay, just to join these two. Okay, this is the station B and this is the north direction and this is north again. So when you sight the station B from station A, so the angle formed here, it is called as a alpha, that is fore bearing, right? Or else you can represent this with the theta. Okay, I am representing this with the theta. So now this is the fore bearing. Now from the same line, if you see the back bearing, okay, see, now this line is parallel and this line is parallel, right? So now we can write this angle as theta, okay, because this line and this line is parallel, so the angle made by this line and this line will be equal, okay, as per mathematical equations, right? So now this angle will be theta, and we know that this is first quadrant 90 degrees and this is second quadrant 90 degrees. So the total angle from here to here, it is 180 degrees. Okay, so now if you know the fore bearing as theta and if you know the back bearing as how much, you can see if you sight the station A from station B, okay, the back bearing can be written as, see, 180 plus this theta. Okay, till here we are going to call it as a back bearing, right? So now we can write that 180 degrees, 180 plus theta will give you the back bearing of a line AB. So now we can write that from the relation. So back bearing is equals to theta. In place of theta you can write fore bearing. So fore bearing plus or minus 180 degrees. Okay, this is the relationship between the fore bearing and back bearing. So when you have the data regarding the fore bearing, you can find out the back bearing also. Okay, so like that, this is one condition. And next, suppose you have another line, that is CD, for example. Okay, this is C and this is D. Okay, so now here the fore bearing of this particular line is, I am coming in a reverse way. So this is the fore bearing of line. Okay, that is theta. Okay, and coming to the back bearing of this DC. Okay, DC line. So this will be your back bearing, right? That is theta. So now here you can write that fore bearing is equals to, okay, fore bearing is equals to theta plus 180. Okay, and back bearing is equals to theta. Okay, so this is how we are going to estimate the fore bearing and back bearing, right? So now if you want to find out the back bearing, okay, so here in place of for theta we can write that fore bearing is equals to, so if you substitute theta value, I mean BB, back bearing in place of theta, so fore bearing is equals to back bearing plus 180. Okay, from this you can find out back bearing is equals to fore bearing minus 180. So now here when you have the data regarding the fore bearing, you can find out the back bearing by using these relations. That means back bearing can be determined by using a fore bearing plus or minus 180 degrees. In the previous condition it is positive, that is plus, and in this condition it is minus. So now by using this equation you can find out fore bearing value, back bearing values. Okay, yeah. Now here we have one condition to find out the back bearing and fore bearing. See, the case 1, okay, if the forebearing of a line is given as the whole circle bearing. So when the forebearing value is given as whole circle bearing, and again we can calculate the back bearing by using the formula forebearing plus 180 degrees. So that too when, if the forebearing is less than 180 degrees, okay. So if the forebearing is less than 180 degrees, that means, see, this is station A and this is station B. Now join this. Now if you see the angle made by this particular line of sight with the line is how much? It is almost 60, less than 60 degrees. Suppose here if you see the forebearing with this, okay, now the forebearing will be less than 90 degrees, because if you see this quadrant, the total angle is 90 degrees and the line is starting here. So now this angle will be less than 90 degrees only, right? Okay. Now if the forebearing value is less than 180 degrees, okay, if the forebearing value is less than 180 degrees, then the formula is back bearing is equals to forebearing plus 180 degrees. Okay, this is the formula. Suppose if the forebearing is more than 180 degrees, okay, if the forebearing is more than 180 degrees, the formula is forebearing minus 180 degrees. That means here, see, now I am citing the line CD, okay, from C station to station D. Now if you calculate the forebearing, this will become till this point. That means it is more than 180 degrees. See, from here to here it is 180, and if you assume this as theta, so 180 plus theta, that means it is more than the 180 degrees, right? So that is why when you have the forebearing value more than 180 degrees, then we are going to use the formula that is forebearing minus 180 degrees. Okay, by using this relation you can find out the back bearing values. So now here we will do one small example problem. Okay, small example for calculating the back bearing. Okay. Yeah, now see, forebearing is given as 60 degrees. So 60 degrees is nothing but in which quadrant it will come? It will come in first quadrant, right? So now see, this is the station A. Okay, now the station B will be here. So now the angle is given as, forebearing is given as 60 degrees. That means the forebearing will be lying in the first quadrant, that is less than 90 degrees. So here this will be 60 degrees. So now how to calculate the back bearing? See, the first case here, back bearing is equals to forebearing plus 180 degrees. That means whenever it is less than 180 degrees, we are going to use this formula. So now here the forebearing value is 60. That means it is less than 180 degrees, right? So now the formula is back bearing is equals to forebearing plus 180 degrees. Okay, so now what is the forebearing value given in the question? It is 60 degrees. So 60 degrees plus 180 degrees. So that will give 240 degrees. So the back bearing is equals to 240 degrees. Okay, the answer is 240 degrees. Okay, this is how we are going to calculate the back bearing whenever the forebearing value is given. Okay, now next question we will see. The forebearing value is 270 degrees. So now here the forebearing, suppose if you take another line that is CD, okay, now this is the station C and this is the station D. Okay, now the forebearing value is 180 degrees. That means from here to here it is making, 270 degrees. Okay, the angle is 270 degrees. So now whenever the forebearing value is more than 180 degrees, so here we have the formula that is forebearing minus 180 degrees. So now to calculate the back bearing, use the same formula, that is forebearing minus 180 degrees. So forebearing value is how much? It is 270, right? So 270 degrees minus 180 degrees. Okay, so now the value is 90 degrees. Okay, so if you subtract 180 minus from 270, then the value is 90 degrees. So the back bearing value is equals to 90 degrees. Okay, so this is how we are going to find out the values of back bearing when the forebearing value is given in the question. Okay. Yeah. Next, case 2. So if the forebearing of a line is given as the quadrantal bearings. So the first case is when the forebearing value is given as a whole circle bearing. Now when the data is given in the quadrantal bearing, so here the only difference is the back bearing will be equals to same numerical number. Okay, so numerically it is equals to the forebearing, but the only change is here we are going to change the directions. Okay, from north for south and east for west. So if it is given with the southwest, then we are going to change it to northeast. Okay, that is how it is going to work in the quadrantal bearing. So now here you can see the example. The quadrantal bearing is given as forebearing is given as in terms of north 30 degrees east. So now the back bearing will be equals to south 30 degrees west. Okay, just in place of north we are going to keep south, and in place of east we are going to place W. Okay, that is west. Okay, this is how we are going to calculate the back bearing and forebearing in the traversing. Okay. Yeah. Now coming to the next topic, that is included angle. Included angle is nothing but it is an angle formed when two lines intersect at a point. So while doing the traversing, we are going to form one area, right? So suppose if you take this area A, B, C, D, E. Okay, this is the closed travels. So when you draw a lines between the two stations, okay, between all these stations, so the intersection of these two lines are going to create some angle. Okay, either interior or else either exterior. So this particular angle is called as a included angle. Okay, so when the two lines, okay, when the two lines intersect at one point, so they are going to form one angle inside the lines and outside the lines also. Okay, so this particular angle is called as an included angle. So now the included angle can be either interior angle or exterior angle. Okay, as we have discussed. So the included angle may be either inside included angle, either interior angle, or else either exterior angle. Okay, yeah, both are called as an included angle only. Okay, the next one, if the bearing of lines is known. Okay, if the bearing of lines is known, that is forebearing or back bearing, then the calculation of included angle will be easy. Okay, so that is why first we have to find out the bearings of the lines. Next, however, in surveying, an included angle is defined as, so normally included angle may be of interior or exterior, right? So, but normal definition for the included angle is an angle measured clockwise from the previous line. Okay, the angle measured from the clockwise from the previous line of a traverse to the forward line. So now, if you see, this is one line and this is one line. So the angle made by the other line, okay, with this line it is making some angle, right? So if it is making in a clockwise direction, okay, if the direction is clockwise, and this angle is called as a included angle. Okay, this is the another definition. Okay, next, case 1. So when the traverse runs in clockwise direction, okay, when the traverse runs in clockwise direction, that is in this form, see, from A to B, B to C, C to D, and D to E, and E to A. So when the traverse runs in the clockwise direction, the included angle will be exterior angle. So whenever the angle is, traversing is done in the direction of the clockwise direction, then the angle formed here, okay, the angle formed here from this line to this line, okay, this is called as an included angle. Okay, that means here it is exterior angle. Okay, when the direction is in the clockwise direction, then the angle formed is exterior angle, and that exterior angle is called as an included angle. Okay, now if you see the second condition, that is when the traverse runs in the clockwise direction. Okay, when the traverse runs in the clockwise direction, the included angle will be the interior angle. See here in the second diagram, if you see, the traversing is done in the anti-clockwise direction. So here, whenever it is in the anti-clockwise direction, here we are going to form included angles. So this included, this interior angle is called as a included angle here. Okay, these are the two cases while mentioning the exterior angle or interior angle. Okay. Now, calculation of interior angles from bearings. So, when you have the data regarding the bearings, okay, then how to calculate the interior angles. Okay. Now see. See here we have the data regarding the fore bearing values. Okay. So line AB is equals to 60 degrees 30 minutes. Okay. Line AB is having a fore bearing of 60 degrees 30 minutes. So now this is one station. Okay. A, and I am taking another station as B. Okay, this is another station B. Now the angle is 60 degrees and 30 minutes, right? So now it will be in the first quadrant only, right? So now draw a line here like this. Okay. Now what is the fore bearing value? It is 60 degrees 30 minutes, right? So now this is the north, and this is also here. You can mention it as a north. Okay. Now the bearing is fore bearing is 60 degrees 30 minutes. Okay, 30 minutes. Now see, this line is and this line is parallel. Okay, this line and this line is parallel. Now this angle will be equals to this angle. That means how much? What is the angle? 60 degrees 30 minutes, right? Now go to the second one. BC is equals to 122 degrees 0 minutes. So now we are going to side this station C. Now the angle is 120 degrees. So it is in which quadrant? Okay, it will be in a it will be in a second quadrant, right? So now here the station will be here, station C. Okay. Now draw one line. So now see, the fore bearing is given as 122 degrees. So now from here to here, okay, from here to here, it is 122 degrees. Because it is 120 degrees, it will be lying in the second quadrant, because till here it is 180 degrees, right? So now 120 degrees. Next one, C to D is 46 degrees. So again, this is less than 90 degrees. So you can assume that it is in a first quadrant. So now this is the station C, and it is in the first quadrant. So the line of sight will be like this. Now this is D, station D. Okay. Now the fore bearing value is 46 degrees. So this will be 46 degrees, right? Okay. This is north. Now next to fore bearing value is DE is equals to 205 degrees. So it will be in a which quadrant? 205 means it is in a third quadrant. So this is 90 degrees, and this is 180 degrees, and this will be next to, okay, 270 degrees, right? So now here we are going to take in the third quadrant. See, from here draw one line, and this will give you the fore bearing value, that is station E. Okay, this is the station E. Now the fore bearing value of DE line is how much? 205 degrees 30 minutes, right? So it is 205 degrees 30 minutes. Okay, now this is the north position. Now again next fore bearing value is 300. So 300 means it is in which quadrant? Fourth quadrant. So now this is north. Now this is the fourth quadrant, right? So now here we are going to draw the line which is going to join the station A. Now what is the angle? 300 degrees. So now from here to here it is 300 degrees. Okay. Now this is the given data. So we have drawn the traversing area. Now we have to calculate the interior angles. That means this angle we are going to find out. Okay. This interior angles we are going to find out. So now first we will start from the station A. Okay. Station A to B. Okay. We are going to start at the station B first. Okay. Now see, this line and this line is parallel. So that is why this angle and this angle will be equal, right? So now this is 60 degrees 30 minutes. And next, if you see this, from here to here it is 180 degrees, right? So now the angle is given till this point. So remaining area we have to find out, right? So the total angle from here to here, it is 180. So if you subtract 122 minus 180, you can get this remaining value, right? So 180 degrees minus 122 degrees. So it will give 8, 7 minus 7 minus 2, 5. So 58 degrees. Okay. So here 58 degrees is the remaining angle. So now you can calculate the included angle. That means from here to here the angle is 60 degrees plus 30. 60 degrees 30 minutes plus 58 degrees. Okay. That is going to give included angle. Right. So now see, we will add that 60 degrees 30 minutes and 58 degrees. So now if you add this 30 minutes and 8 degrees, 118. Okay, 118 degrees 30 minutes is the included angle here. So write down here 118 degrees 30 minutes. Okay, this is the included angle of B. Okay, and next one, coming to this point here, see, this angle is 58 degrees, right? So now see, this line and this line is parallel. Now if the angle is 58 degrees, now this angle will be how much? 58 degrees only. Okay, so now here see, the total angle from here to here, it is 46 degrees. So right, so now if you calculate the, if you want to calculate this angle, that means if you, the total angle here, it is 90 degrees. So if you subtract 46 degrees from 90 degrees, then you can get the remaining angle. That means 90 degrees minus 46. So now 8 minus 4, 44 degrees. Okay, so 44 degrees will give you the remaining angle, that is 44 degrees. Okay, 90 degrees. So the total angle is 90 degrees. Okay, now this is 44 degrees. Next, here also you can write, you can calculate the remaining angle, because this is 58 degrees, right? Here at one side it is 58 degrees. So the remaining angle will be 90 minus 58. So it will give 2, 8 minus 32. So this will give 32 degrees. Okay, now the remaining angle will be 180 degrees. So 180 degrees plus 44 plus 32. Okay, so 6, 12, 15, 256. Okay, so the total interior angle is 256 degrees. Okay, 256 degrees is the interior angle, included angle. Okay, for station C. And next one, coming to this particular angle. Okay, here this is the included angle, right? So now see, this is 44 degrees here. Okay, now if this is 44 degrees, okay, this will be 44 degrees again. Okay, because this line and this line is parallel. So this is 44 degrees and this is 44 degrees. Now if you want to calculate this remaining portion, see, here the angle from here to here, it is 205 degrees, right? So now if you want to calculate the angle, if you want to calculate the angle from here to here, okay, then what will be the formula here? The total angle here, it is 180 degrees, right, from here to here. So now from 205 degrees 30 minutes, if you subtract the 180 degrees, then you will get the remaining portion, right? So now 180 degrees subtract, so 30 minutes, 5 degrees, 2. Okay, so now 25 degrees 30 minutes is the remaining angle, that is this one is 25 degrees 30 minutes. Okay, so now see here, in this particular quadrant, you know this angle, that is 44 degrees, and you know this angle, that is 25 degrees 30 minutes. So the remaining angle will be, add 25 degrees and 30 minutes plus 44. Okay, 44 degrees, then that will give 30 minutes, 9 degrees, 69 degrees 30 minutes. So these two are giving 69 degrees 30 minutes. So from 90 degrees, okay, from 90 degrees subtract the 69 degrees, because if from this quadrant, if you subtract this angle and this angle, then automatically you can get the remaining angle, that is included angle, right? So now 90 degrees minus 69 degrees 30 minutes. Okay, now first calculate this one. So 181, right? Sorry. So from 8, if you subtract the 6, so 21 degrees you will get. So from that you have to subtract 30 minutes also. So the angle is 20 degrees 30 minutes. Okay, now the center angle is 20 degrees 30 minutes. Okay, that is the included angle at the station D. Okay, now we will go to the station E. Okay, so in the station E, from this particular position to this one, the angle is 300 degrees, right? So now you can tell that the remaining angle will be automatically 60 degrees, right? Okay, so the total quadrants will include 360 degrees angle, right? So out of that, the 300 degrees angle is given as a fore bearing. So now the remaining angle will be 60 degrees 30 minutes, right? So now if you calculate this one, okay, yeah, okay, 60 degrees 30 minutes, and next one, see here it is 25 degrees 30 minutes. Okay, so now this will also be equals to 25 degrees 30 minutes, because this line and this line is parallel, and the angle made here it is equals to the angle made here. So now the total angle will be equals to 60 degrees plus 25 degrees 30 minutes. Now 30 minutes 5 degrees 8. So 85 degrees 30 minutes is the total included angle here. 85 degrees 30 minutes. Okay. Now next, see this line and this line is parallel. Okay, now if this angle is 60 degrees, okay, now this angle will also be equals to 60 degrees. Now see, we know the angle here fore bearing, that is 60 degrees 30 minutes, and we know this angle, that is 60 degrees. Okay, now we have to calculate the remaining angle. That means the total angle here it is 180 degrees. So 180 degrees minus 60 degrees 30 minutes. Okay, first add these two, that is 180 degrees. Yeah, okay, 60 degrees 30 minutes and 60 degrees. Okay, now if you add these two, it will give 120 degrees 30 minutes, right? So 120 degrees 30 minutes. Okay, that will give you the remaining angle, right? So now see, from 180, if you remove the 120, remaining angle will be 60, but here we have 30 minutes, so 59 degrees 30 minutes is the remaining angle, included angle, 59 degrees 30 minutes. So now this is the included angle here. So now if you write all these angles, okay, the included angles, so the angle, included angle of A is equals to 59 degrees 30 minutes, okay, and included angle at station B is equals to 118 degrees 30 minutes. Okay, and next one, included angle at C, station C, is equals to 256 degrees. So 256 degrees. And next one, included angle at station D, that is 20 degrees 30 minutes. So at station D, the included angle is 20 degrees 30 minutes. Okay, 20 degrees 30 minutes. Okay, now at station E, the included angle is 85 degrees 30 minutes. Okay, so these are the included angles based upon the given data, that is when the fore bearing of the traversing is given, then we can calculate the included interior angles. Okay, this is the procedure for finding the included angles. Okay, now adjustment of angles. So now after calculating the included angles, whether it is correct or not, how to cross check means, see, in a closed traverse, okay, if you take the closed traverse, the theoretical sum of interior angles should be equal to 2n minus 4 into right angles. That means 2n minus 4 into right angles means 90 degrees, right? So the all the included angles, okay, the sum of all the included angles should be equals to this particular value, that is 2n minus 4 into 90 degrees. So where n is the number of sides of a traverse. So in the previous example you have seen, here we have how many sides? 1, 2, 3, 4, 5. So here we have 5 sides. So in place of n we are going to substitute the value of 5. Okay. So the total of this particular angles, okay, if you add this all the angles, included angles, that should be equals to the 2n minus 4 into 90 degrees. Okay, then your calculated angles will be correct. Okay, and see, if the theoretical sum of the exterior included angles, external included angles should be equals to the 2n plus 4 into right angles. Suppose if you calculate the exterior included angles, okay, not interior, if you calculate the exterior angles, then how to cross check means you have to find this value, that is 2n plus 4 into right angles. So if this value is equals to the sum of the angles, then your calculation is correct. Next, coming to the next topic, that is magnetic declination. Okay, so horizontal angle between the true meridian and magnetic meridian is called as a magnetic declination. Suppose if you take the Earth surface, now here we have pole and here we have pole, that is here we have north pole and here we will be having south pole. So if you join the one line, okay, now this particular line is called as a true meridian. Okay, true meridian. And if you see, and due to the magnetic declination, we have another line that is like this. Okay, this is the true north. Okay, and this is the magnetic north. Okay, magnetic north and magnetic south. Okay, now this particular area is called as a magnetic meridian. Okay, so now the magnetic declination is nothing but the horizontal angle between the true meridian and magnetic meridian is called as a magnetic declination. So now this angle, okay, this is a true meridian, right? So now this is a magnetic meridian. So the angle formed in between these two meridians is called as a magnetic declination. Okay, so now the magnetic declination is not constant even for a particular place. Okay, this particular magnetic declination is not constant. Okay, for with respect to place and time, it is going to change. Its value continuously changes. Okay, changing declination is called as a variation. So from one place to one place, or from one time to another time, the magnetic meridian will change. Magnetic declination will change. So that declination is called as a variation here. Okay, so now here we have different types of declinations here. See, the first type of declination is eastern declination and second one is western declination. Okay, so now we will discuss about each and every declination clearly. See, suppose the declination is considered to be eastern declination or positive declination if the magnetic north is on the east side of the true north, as we have discussed in the previous slide. See, this is the surface and this is the true north and this is the true south. Okay, this is the true north and this is the true south. Now see, or else I will draw here. Okay, now see, this is true north and this is true south. Okay, if you join this line, okay, this is the true meridian, right? Now if you take the magnetic meridian like this, okay, this is the magnetic south and magnetic north. So this is magnetic meridian. Okay, now see, if the declination is considered to be eastern declination, if the magnetic north is on the east side of the true north. Suppose if you see, this is the north and this is the east side, right? So where our magnetic meridian is lying, it is towards the east side. Okay, this is making an angle with the east side. So this is the magnetic declination, right? So we can represent that with the delta E. So now if the magnetic north is on the eastern side of the true north, okay, then it is called as a eastern declination. This type of declination is called as an eastern declination. Okay, suppose, okay, here if you want to find out the true meridian, okay, true bearing of the line, then the formula is true bearing is equals to magnetic bearing plus declination. Okay, so magnetic bearing is this one and this is the declination. Suppose if you want to find out the true bearing of one line, that is point A. Okay, now this is the line A. Now this is the angle made by this magnetic meridian. Okay, some alpha angle. So now if you want to find out the true bearing of line A with respect to true north, so the formula is true bearing is equals to, see, this is the magnetic bearing, right? So magnetic bearing is alpha plus, what about the declination here? Delta E. So delta E. So this is how we are going to find out the true bearing of a line, okay, with respect to eastern declination. See here, it is towards the east side. Okay, yeah. And next one, coming to the western declination. Coming to the western declination, see, this is the true north and true south, right? So the declination is considered to be western declination or negative declination when the magnetic north is on the west side of the true north. So if the magnetic north is on the west side, okay, magnetic north is on the west side, that means like this, then this type of declination is called as a western declination, okay, delta W. Okay, suppose if you have the line A, okay, so the same line we are going to find out the true bearing. Now see, this is the true bearing, okay, this is the bearing with the line A, right? So now the formula is true bearing is equals to magnetic bearing, okay, this is the magnetic bearing alpha, okay, the total angle made by this particular magnetic north is alpha. Now see, this is the true bearing, right? So now if you find out the true bearing, the magnetic bearing, okay, magnetic bearing is here I am taking as alpha minus, what about this declination? Magnetic declination. So from the total magnetic bearing, if you subtract the magnetic declination, then you will get the true bearing of the line, right, with respect to true north. So now this is the formula, alpha is nothing but here magnetic bearing, okay, magnetic bearing is the alpha value and alpha W is equals to declination. Okay, so like this we are going to calculate the eastern declination and western declination. Okay, if it is lying in, towards the east, then it is called as a eastern declination and the formula to determine the true bearing is magnetic bearing plus declination. Okay, and if the bearing, okay, if the declination is lying towards the west side, okay, then this is the diagram here you can see, and it is called as a western declination and the formula is true bearing is equals to magnetic bearing minus declination. Okay, so like this we are going to calculate the eastern declination and western declination, that will come under magnetic declination. Okay, next one, here you can see the diagram. So eastern declination means, see, this is the true north and this is the true south. Okay, now this is the line where we are going to find out the true bearing. Okay, so now see the angle, the bearing made with the true north. Okay, the bearing made with the true north is TB, true bearing. Okay, this is the true bearing of the line. Okay, and next, okay, this is the magnetic north. So the bearing formed with the magnetic north is called as a magnetic bearing, right? This is the magnetic bearing and this particular declination delta E, okay, this is the eastern declination. Okay, it is towards the east direction, that is why it is called as a eastern declination. And here also you can see the same line is taken as a reference line and the bearing made with the true north is called as a true bearing. Okay, and coming to the magnetic bearing, the angle made with the magnetic bearing is called as magnetic bearing and the declination forming from the true north to magnetic north is called as a delta W here, that is declination, western declination. Okay, yeah. Now coming to the variation of magnetic declination. So here the declination at a place does not remain constant but it varies from the time to time. So the declination is not constant. Okay, so it is going to change from time to time. So that is why basically there can be 4 types of magnetic declinations. So this declination is changing with the time to time, right? So that is why here they are classified as 4 types. See, at a place based upon the pattern of this variation. So how the variation is occurring, okay, how it is going to change. So based upon that pattern, they have classified into 4 types. Okay, the first one is secular variation, and second one is annual variation, and third one is diurnal variation. Okay, and next one irregular variation. Okay, so these are the different types of variations. And next one, secular variation. So secular variation of is nothing but it is a declination occur. I mean, it is a type of declination. Secular variation is nothing but it is a type of variation where the declination occurs continuously over a long period of time. Okay, so it is more than 1 year. Okay, the declination or else the variation will be observed with the time period of more than 1 year.